Multiplying and dividing fractions are simple enough, but what about adding or subtracting fractions? Well, that's where it gets a little bit more tricky. Say, for example, we have this equation, 1/4 plus 2/4. How do I solve that? Well, let's think of a cake that has been split into 4 equal parts. Somebody comes along and eats 1/4 of the cake. Somebody else comes along and eats 2/4 of the cake. 1/4, 2/4. So how many quarters of the cake have been eaten? Well, it's easy. Just count them up. 1, 2, 3. So 3/4. So 1/4 plus 2/4 is equal to 3/4. Let's have a look at what I did here. Essentially, what I did was I kept the denominators the same all the way through. 4, 4, 4. And I just added the numerators. 1 plus 2 equals 3. This is the rule when the denominators are common. So, when the fractions that we're adding have common denominators, the same denominators, we just add the numerators through, and we keep that denominator the same. So, say we have 1/5 plus 3/5 plus 7/5. Well, they all have common denominators, so what's the rule when the denominators of the fractions are the same? You just keep the same denominator and add the numerators through. So 1 plus 3 is 4, 4 plus 7 is 11. So that's my answer. Similarly, this works for subtraction. So say I have 10/9 minus a 9th. Well, because their denominators are common, we keep the denominator the same, and we just work out the numerators. So 10 minus 1 is 9. If I was to add another part to the equation, I just keep the denominator the same because the denominators are common in all the fractions, and I just work this out linearly. 10 minus 1 is 9, 9 minus 3 is 6. So that would be my answer. What if, however, the denominators are not the same? What if they are not common? Well, that's what we're going to look into now. So we learned that the rule for when the denominators are common, you just add the numerators through, or you subtract the numerators through. What if the denominators are not common? So what if we have 1/4 plus a 1/2? Well, you can't just add the numerators through because they don't have common denominators, so the rule doesn't work. You would get the wrong answer. 1/4 plus a 1/2 is not 2 over... You can't do that. You can't add the numerators through. So what do you have to do? Well, looking at the rule, you can add the numerators through if the denominators are common. So what you want to find is a common denominator, so then you can just add the numerators through. So you want to find a common denominator. But how do you do this? Well, one of the easiest ways to work out the common denominator is to just multiply the two denominators together. So 4 times 2 is 8. So that's a common denominator. But before we get into that, let's have a look at what common denominators mean. What does a common denominator mean? Well, it's all to do with factors and multiples. So factors and multiples. Very quickly, if you don't know what these words mean, say we have 2 and 4. 2 can be times by a number, a whole number, not a decimal, an integer number, to give 4. Therefore, we can say that 2 is a factor of 4 because it can be times by a whole number to give 4. And we can say that 4 is a multiple of 2 because 2 can be times by a whole number to give 4. If we look at 10 and 5, 5 can be times by a whole number 2 to give 10. 2 can be times by 5, a whole number, to give 10 as well. So both 5 and 2 are factors of 10, and 10 is a multiple of both 5 and 2. So when we look at a common denominator, we want a number that is a multiple of both 4 and 2. So both 4 and 2 should be able to be multiplied by a whole number to give 8. And when we multiply it together, this is achieved because 4 times 2 will give 8 and 2 times 4 will give 8. So it's a common denominator. But what about if this was 40 and 20? Well, suddenly you end up with 40 times 20, which would give you a very big denominator. And you don't want that. You want to keep it as small as possible. So what you want is not just the lowest common denominator, not just the common denominator, you want the lowest common denominator to make it easier for yourself to calculate. So in situations like this, because it's small, you can just multiply it through together. But if you actually look at these two numbers, 4 and 2, you can see that the lowest common denominator would actually be 4, because 4 times 1 is 4, and 2 times 2 is 4. So 4 is a multiple of 4 and 2. But what if the numbers weren't that easy? Like, what if you couldn't simply tell that there would be a common factor? For example, say we had a quarter plus 2 over 10. What could we do now? How can we find the lowest common denominator? Well, we use prime numbers. Prime numbers are key. And what are prime numbers? Prime numbers are any number that can only be divisible by itself or by 1. And every number can be divided by 1. So, for example, 2. 2 can be divided by itself to give a whole number. 2 can also be divided by 1 to give a whole number. But can it be divided by anything else to give a whole number? 2 divided by 3. Well, that gives you a decimal, not a whole number. So therefore, 2 can only be divisible by itself and 1 to give a whole number. Therefore, it fits the criteria of being a prime number. 2 is a prime number, and it is the only even prime number and the smallest prime number. 0 and 1 are, by rule, not prime numbers. So the first prime number is 2. What about 3? Is 3 a prime number? 3 can be divided by itself, and it can be divided by 1 to give whole numbers. Dividing it by anything else will give us a decimal. Therefore, it is a prime number. Last example, what about 4? 4 can be divided by itself to give a whole number, and it can be divided by 1 to give a whole number. Can it be divided by other numbers to give a whole number? Yes, it can. Therefore, it does not fit the criteria of being a prime number because it can be divided by another number to give a whole number. So 4 is not a prime number. So just a quick list of the smallest prime numbers in ascending order. It's 2, 3, 5, 7, and 11, and then the next one's 13. This should be all of the prime numbers that you realistically need to know for GCSE level. You don't need to memorize them, but it would be helpful. So prime numbers help us find the lowest common denominator, because what they let us find out is something called the highest common factor. So you remember what factors are. So the highest possible factor that applies to both the numbers 4 and 10. So it's a common factor and it's the highest possible one. And using the highest common factor, we can find out the lowest common multiple. So a common multiple between both numbers, which is the lowest possible value, which is what we want to find. LCM, lowest common multiple, is equivalent to the lowest common denominator. It's just two ways of saying the same thing. So what we want to find out first is the highest common factor to let us work out the lowest common multiple, which is the same as the lowest common denominator. So let's get started. This is the method you would use. Look at each number individually, 4 and 10. Divide the numbers by the smallest possible prime number that will fit into it evenly. So the smallest possible prime number that 4 can be divided by to give a whole number is 2, and that gives me 2. I do the same thing again. What is the smallest possible prime number that can fit evenly to give a whole number into 2? 2. 2 divided by 2 is 1. And I stop here because I could just keep dividing 1 by 1, but 1 is not a prime number, so I just stop here. Now I do the same for 10. What is the smallest prime number that can go into 10? 2. 10 divided by 2 gives me 5. What is the smallest prime number that can go into 5? 5. And that gives me 1. Now I can write both numbers, 4 and 10, as a product of their factors, because these here on this side are the factors of each number. So 4 is equal to 2 times 2. 1 is also a factor of 4. So if ever a time a question asks you to write the factors of a number, remember that 1 is always a factor. But here it's not really important because we could just keep on timesing by an infinite number of 1s, but you don't need to worry about that. Let's just say there is a 1 there. But in reality, when you're doing this step for finding the lowest common denominator, you don't need to write the 1 there because it gives you the same answer. 10 is 2 times 5 times 1. Now we look for common factors between the two of them. So we look for pairs. There's a 2 here and there's a 2 here, so we can pair that off. There's a 2 here, but there's not another 2 that I can pair it with, so I just ignore it. There's a 5 here, but there's no 5 here to pair it with. And there are common 1s. Now I take the common sets of numbers. So what is common between these two numbers? Which factors are common? 2 is common and 1 is common. Now I times them together, and that gives me the highest common factor. So I take the common factors, pair them off, and multiply them together to get the highest common factor. I don't do 2 times 2 times 1 times 1. I just take the pair of them, 2 times 1, and that gives me the highest common factor. Now how do I find out the lowest common multiple or the lowest common denominator, the LCM or the LCD? Well, this is what I do. I times the highest common factor, I times that by the numbers I ignored previously. So I times it by 2 and 5. And the highest common factor we worked out was 2. So 2 times 2 times 5 gives me 20. So the lowest common multiple or the lowest common denominator of 4 and 10 is 20. Let's just check that. Is 20 a multiple of both 4 and 10? 10 times 2 is 20, so 20 is a multiple of 10. And 4 times 5 is 20, so 20 is a multiple of 4. So this is our common denominator. Now, remember what we said about equivalent fractions? What we do to the bottom, we do to the top. So I times 4 by 5 to get to 20. So I have to do the same at the top to make sure that the value over here is the same. So 1 times 5 is 5. So this fraction here is now equivalent to this fraction. And I want to do the same to the next one. So 10 times 2 gives me 20. So I have to do the same to the top to make sure that the value of both fractions are the same. So 2 times 2 is 4. So this fraction is equivalent to that, and that fraction is equivalent to that. And now both of these fractions have the same common denominator. And the rule is I can just simply add the numerators together. So this is familiar, right? So now we can just add the numerators through. 5 plus 4 is 9, and keep the same denominator, 20. Using this whole prime number method to find out the highest common factor and therefore the LCM and LCD is really useful when you can't seem to tell what the lowest common denominator could be. Also, you don't want it to become insanely big. Say, for example, we just had times the 4 and the 10 together. It worked for the previous example of the 2 and 4, but in this case, it would give us a very big common denominator, so 40 and 40. So 4 times 10 gives me 40, so I have to do the same at the top, 10, and 10 times 4 gives me 40, so I have to do the same at the top, 8. So 18 over 40, and then I'd have to simplify that. Before I didn't have to simplify. Over here I do though, because both are multiples of 2, so they can be factorized. And here's where it would stop, which was my previous answer before. So doing this skipped this last simplification process here. However, instead, if it was 40 and 10, it would give me an insanely huge lowest common denominator of 400. And then I would have to work out, okay, 40 times 10, and then it just gets a little complicated. So using the LCM method is really useful when you have large numbers here or when you can't tell what the lowest common denominator should be. Let's do another example. This time let's do subtraction. 4 divided by 27 minus 6 divided by 50. Well, I could times 27 by 50, but if I don't have a calculator, that is hard to do, to find a common denominator, and also it would give me a very big number. But I can't tell what the lowest common denominator should be. So what I would have to do here is use the prime method of first finding out the highest common factor and then finding out the lowest common multiple, which is equivalent to the lowest common denominator, which is what I want here. So let's have a look at both the denominators. And now let's use the prime method. So what is the smallest possible prime that can go evenly into 27? Well, 2 can't. So can 3? Yes. So 27 divided by 3 gives me 9. And I do it again. What is the smallest possible prime number that can go into 9? 3. And that gives me 3. And I just keep doing this until I get 1. Now 50. What is the smallest possible prime number that can go into 50? 2. And that gives me 25. And then that would be 5. And that would give me 5. And 5 here. So these are the factors, and 1 of 27. And these are the factors, and 1 of 50. So now let me express them as a product of their factors. 27 is equal to 3 times 3 times 3. And let's just add the 1 there for good measure. 50 is equal to 2 times 5 times 5 times 1. But remember, you don't really have to write the 1s here. Now, let's look for pairs of numbers. Are there any pairs of numbers?